So the next stage prior to fitting the inner primary chain case is to ensure all of the bolts and nuts that are behind the primary chain case are all torqued correctly, because they're much more difficult to get at when they're shrouded by the primary chain case. The other things that I've done in the meantime, having cleaned up the bosses for the clutch hub so that I have 1mm of clearance, and cleaning the hole where the crankshaft pulley runs, again to ensure that I have at least 1mm of clearance, means that when I fit this now, this should be the final time. We'll see. The other thing I have done is to ensure that the crankshaft and gearbox shaft are as parallel as I can get them, such that I should have a neutral running belt. I've also set the tension on the belt and checked that, because it's much easier to do without the primary chain case in, and obviously redone the chain, because as you move the gearbox, of course, you change the tension on the chain. According to the RGM, once the belt tension is set, it should be set for a good long while. However, you need to make sure that the belt is running either neutral or slightly towards the engine, rather than actually trying to climb the outer keep to stop the belt coming off the engine, which is the normal situation as I understand it. So, having got that done, I can start fitting the primary chain case. One of the things that you have to keep off until the primary chain inner is fitted is the spacer that actually keeps the circlip that actually positions the back of the clutch hub. You also make sure that the shims are actually in place. So, fitting the primary chain case, make sure that your gasket is correctly in place, the shims are in place, and that the keeper that actually, and spacer that actually has a recess in it, I'm not sure if you can see that fits over that circlip, but that has to go on afterwards, because of course the felt seal that actually runs on this. The quarter UNC screws, 3 off, are now fitted with the tab washers behind them. The tab washers have a tang that fits into the 2 protrusions on the inside of the primary chain case, and they're all fitted correctly. So they now need to be torqued to 6 foot-pounds. So we've set the torque wrench on 6 foot-pounds, and six. And 6. Okay, so the next thing is to ensure that the key is actually in the correct position on the crankshaft, and then we can fit the pulley. Of course, I'm actually going to put the belt on. I just want to make sure. I had some issues and had to relieve the keyway slightly to actually ensure that the pulley would actually fit on the taper, rather than being held off by the keyway. So we are almost ready to fit the belt and the pulleys. We are making sure that we have a 1mm shim behind the clutch basket, and this ensures that we actually have the 1mm of clearance between the clutch basket and the primary cover. Okay, rest that on there, and we'll guide that in there. That goes on, and that goes on. There we go. So we now have the clutch basket and the primary drive and the belt in place, although until we actually bolt this up, it's difficult to actually check the tension of the belt. As I say, without the primary chain on, the tension, which has been set by the dual positioners on the gearbox, makes it easier to access those parts and to actually do the setting. You need to actually make sure that the front pulley is actually seated on the taper, which it is. Next, you actually fit a spacer which has got the counter bore towards the pulley, and then the belt keeper with the bevel towards the belt. Okay, on the clutch on gearbox main shaft, we need a keyway, a tab washer, and then we have a standard washer, and then we have an extended nut with an oil seal in it, and that fits over the centre, and then the oil seal holder screws in. I'm going to need a special screwdriver for that. I think one for the clutch springs on the Triumph clutch will actually fit that. We'll go and get that in a minute. The other thing we need is to fit the key. So having fitted the key for the rotor. And I'll put it. And now I'll fit the rotor. Now this is a twin, so we use the twin marks. The other side, of course, is for triple, and gives you some timing marks for that. So that goes on, and then we have the lock washer and the nut. We'll get a spanner or socket actually to do that up. Having temporarily fitted the footrest and the rear brake lever, and with the gearbox in gear, I now can torque up the centre nut on the clutch to the requisite 70 foot-pounds. There we go. So that's now done up. The idea is to, well, the next part is to tighten up the centre that holds the oil seal to stop the gearbox oil travelling out into the primary chain case. Once we've done that, I can then bend the tabs down and go on to the stage after that, which is to fill the clutch. Once the clutch is on, I can then tighten the rotor nut to the, I believe it's 80 foot-pound, but I will look that up. And then the primary chain will be ready to go. So I have a modified screwdriver for adjusting the screws on a Triumph 500 clutch, and it does actually fit into there for the oil seal. So make sure the push rod comes out and it's completely free, so that's good. I now have the tabs bent over a little bit, and we'll just tighten them up onto the clutch hub nut, and just make sure that the tab is actually sat in the hole. I have a clutch pack that came with the clutch hub from RGM, and we started off with a thick plate. As I've said in a previous video, this clutch stack works out at 31mm height, and we start off with a thick plate on the inside, which is 3.88mm. Go. And then a friction plate, which is 3.78mm, and a plain plate, which is exactly 2mm, friction plate, which is 3.7mm, and then a plain plate, which is 1.93mm, and then a friction, which is 3.3mm, And then another plane, just 1.93 millimeters. There we go. And another friction, just 3.3 millimeters. And then the thick aluminium thrust plate, which is 7.22 millimeters. Okay, so we have a little bit of ribs, so when the clutch comes out, it doesn't fall off. And the next stage is to fit the pressure plate and the circlip that goes around it. Now this I've not done before. This is very different type of clutch than the Triumph ones I'm used to. I have a couple of Triumph Tridents, one of which I've had since 1974, and that's had a few clutches and clutch plates in, but that's a Borg and Betch single plate clutch, very different to this. And then of course the Triumph 750s and 500s that I've had, which have a 3 or 4 spring clutch, which you can actually use that screwdriver to tighten the springs and set the thing coming off. This is a different thing to that. This is the spring for the clutch. I've measured the depth in here. There's over 19.9 millimeters, and the depth of that nut is at 18 millimeters, so that will fit on there without any interference. So I bought a tool for tightening the spring, because you obviously have to have that either flat or slightly concave rather than convex. So having put the parts in here and then tightened up the lock nut inside, this is a 1/4 inch, 3/4 inch nut, and the idea is to hold this one and then tighten this part up, and basically what that does is pushes these arms down and tensions the spring. There's a lot of energy stored in this, so it's a little risky. So that's about flat. Having removed the clutch spring compressor, which has a hole in the middle for the push rod should you need it, the clutch circlip is in there, seems to be in there fine, and I've attempted to set the clutch. So that's where it's tight, and it says take it back 3/4 of a toe, which is approximately there. Of course, one of the next jobs is to fit the clutch cable and the clutch lever, but I have to sort that out first. So having got that, I can now refit the brake, the rear brake arm, and let's put some nuts on that to keep it in place. And I I can then use, I'll put the gearbox back into gear, and I can use the rear brake, gearbox, clutch to hopefully tighten the rotor to 80, I think it's 80 foot-pounds, must look that up just to make sure it's right. Good. So, magic book. Rotor nut, 80 foot-pounds. £80 with the clutch fitted. I have fitted a clutch cable and then the clutch operating lever and approximately tightened or set the push rod length, although I need to go back and do that again. And the idea is, in the gearbox there's an arm that actually has to be pulled forwards, and there's a very good example of how that all works in the Mk2A's gearbox servicing video available from the Norton Owners Club. And once that's set in the correct place, and by operating the lever, the clutch now disengages, and it is very light, especially compared to a Norton Commando, to a Triumph Trident, which is a Borg&Beck single plate car clutch out of a Mini. So the next stage is to fit the alternator.